Hi there folks, welcome to video number 156. This video is on translation. It's the third of the four transformations, out of the four transformation topics that I'm teaching you in the world of foundation maths. And a translation is, or to translate, means to move. Okay, we don't use the word move from one place to another, we say translated from one place to another. And a column vector is the thing that makes that movement happen. That translation occurs because of a column vector. And a column vector is just some long brackets, you see in the star up there, long brackets, number on the top, number on the bottom. The number on the top is the x-axis movement, left or right. So if it's a negative number, goes left, positive number goes right. And if it's a positive number on the bottom, then we're going to be moving up, and a negative number on the bottom, we're going to be moving down, okay, because that's the y-axis movement. So that's understanding what a column vector is and does. So again, I've stated you might find tracing paper a useful tool to do this. Again, not something I've got the luxury of in the computer. And you'll either be asked to translate or describe a translation. In either case, you're going to need to use a column vector. Either use it, the given one, or state what the column vector is. And I've told you what the number on the top does. I've told you what the number on the bottom does. Okay, so number on the top, movement left or right. Number on the bottom, movement left. Movement on the bottom is the movement up or down. Okay, so in question number 1, I'm going to zoom into it for you, and we're going to have a little look at that. It asks us to translate shape A using the column vector 3 minus 5, label it B. Okay, so I'm just going to choose any one of the 4 vertices of shape A, and I'm going to move it 3 to the right and 5 down, because that's what that column vector is telling me to do. Positive 3 means 3 right, negative 5 on the bottom means 5 down. So I'm going to choose this point here, the far right bottom vertices of shape A, move it 3, 5, 1, 2, 3 squares to the right, 1, 2, 3, 4, 5 squares down. Okay, this is just in a random box with no coordinates whatsoever. Okay, so we just count the squares there, 3 to the right, 5 down. That point is the corresponding point here, right, on our new one. Do it one point at a time if you want to. 1, 2, 3, 1, 2, 3, 4, 5. Okay, might be useful for more complicated shapes to do it that way. 1, 2, 3, 1, 2, 3, 4, 5. Okay, and you see where the other one's going to go surely. By now, it's going to go there. Okay, so what I'm going to do is I'm just going to join those up with some straight lines. So I'm actually drawing the shape in where it should be. And then I'm just going to label it B. Alright, so it's actually a relatively simple thing to do. Alright, the whole shape has translated using the numbers in that column vector. Okay, right, let's have a little look where it makes a bit more sense in context or in a coordinate grid. Okay, so in number 2, we've got to translate shape C using the column vector -1, -2. So this column vector, what you should do every time you see a column vector is think about what it means. This means movement to the left 1 unit, and this means movement down by 2 units. Label this shape D. Okay, so we're going to need to go units this time. So each one of these squares is actually worth half, and this is where I made a mistake last time. I was too quick to do the question, didn't bother looking at the scale. All right, 2 squares is 1 whole unit, so we need to move this point here, all right, or any of the points, but this point here 1 whole unit to the left, and that's going to be 2 squares. Okay, so I'm going to move that over there, and then 2 units down. So 1 unit, 2 units. Okay, that's where that point is going to now be. Our new shape that we're going to draw is going to start there. So I'm going to just draw that in. Okay, exactly the same size, exactly the same shape. Okay, it is what we'd refer to as a congruent transformation. Okay, and I didn't mention that in the last video, I don't think, or the last 2 videos I should have done. But congruent transformations mean that the shape stays exactly the same size and exactly the same shape. It's just somewhere else in the grid. A rotation is one of those, a reflection is one of those, and a translation is one of those as well. Okay, 3 types of congruent transformation, or 3 ways to congruently transform shapes. And there we go. That's where it is. I just did that whilst I was talking about congruent shapes. And yeah, it's every single point has moved 1 unit to the left and then 2 down. Okay, and you'll see that that top point there, 1 unit to the left and 1 2 down. All right, pretty simple. Just count, don't just count the squares, count the units. All right. Oh, didn't mean to zoom in there, but I did. Okay, right, let's have a little look at this third and final question. I might well need to get the pen up to do this. So have a look over here. Right, describe fully the single transformation that maps B onto A. So we're going from B to A this time. Okay, so be careful here. You might have looked at A to B. Now that, it would be a different column vector movement, wouldn't it, if we were doing that? So I'm just going to get the red pen there. And describing the single transformation, well, it's in a translation video, so we know it's a translation. We have to use that word translates. So translation, and then we use the column vector. So using, and then we state what the column vector is. So we're going to put some long brackets in, a number at the top, a number at the bottom. Now, if we were going from A to B, it would be the exact opposite of B to A. We're going from B to A. So B's got to go to A. I'm going to choose this point here. It's on the corner. And I'm going to go 1, 2, 3, 4, 5, 6 units to the right, and 1, 2, 3 up. Okay, so that's going to be 6 and 3. Right, and just check that with any of the other points there. So 1, 2, 3, 4, 5, 6, 1, 2, 3. Okay, and if you wanted to go from this one to the corresponding one over here, 1, 2, 3, 4, 5, 6, 1, 2, 3. Okay, so it's definitely a translation using this particular column vector. Now, if we wanted to go from A to B, that would be -6, -3. Okay, -6, -3 would get us from A to B, the exact opposite of 6 and 3 in the long brackets there. All right, hopefully all of that makes sense to you. Please watch the next one. That's the last of our 4 transformations, enlargement. And yeah, watch some more after that. Continue to practice your mathematical skills. Click the links in descriptions and look after one another. Thanks very much. See you later.